Hello, my name is Jack Michael. This is Physics 2212, Lab 2, Charge Tape Revisited. A brief introduction of what we're going to be going through. So the purpose of this lab is to represent the tape as a charge, a line of charges rather than a single point charge like we did in Lab 1. This will broaden our understanding of the physical properties that were happening in Lab 1 to more accurately reflect the real-world physical model that's happening in the experiment. With a more accurate model, it is possible to determine a more accurate charge of the tape. And the findings are that the new charge found is 2.79 times 10 to the negative 8th Coulomb, which is 3.25 times larger than the charge found in 1 for the tape, which is pretty significant. The experimental model we're using is the same model as from Lab 1, and the computational model is the GlowScript code that we're using and editing based off of the starter code, which represents the tape as a continuous line of charges to find the electric force and charge distribution to eventually find the charge that's acting, that is present in a single tape. The key assumptions is that air resistance is ignored. Each U-tape carries the same amount of charge, and charge is uniformly distributed along the tape. Three key concepts. So we're using Newton's second law of force equals mass times acceleration. So since there is no movement, or also change in momentum over time. So since there's no movement, we know F net is equal to 0. With this, we can use the gravitational force to be the downward force applying, which is mass times gravity. And then the upward force that is counteracting the gravitational force is the electric force, or given by Coulomb's law, of 1 over 4 pi epsilon naught times the charges of both objects and over the distance squared. The key assumptions, again, air friction or resistance is ignored. We're taken to be 0. Both tapes are equally charged, and the tapes act as a line charge in this model rather than a point charge like in Lab 1. Procedure, again, just to go over it real quick, you stick a piece of scotch tape with a handle down to the table, lay another piece on top of it with a U. This one also has a handle. Then you rip them apart to give the top tape a positive charge. You do that twice. You suspend one of the U-tapes over a gap, and then you take another U-tape and record the distance between each other to eventually model in GlowScript. Observations: the U-tapes which had similar charges repelled each other, such as described in Coulomb's law. The U-tapes were attracted to objects that were said to have negative charge, and so they have a positive charge. And the two U-tapes repelled off each other, had a distance of 1.5 centimeters between them. So these are the three key values that we're going to be taking into our GlowScript model of the tape length being 0.3 centimeters, or 30 centimeters, or 0.3 meters. The vertical distance being 1.5, or 1.5 centimeters, and the mass being 0.0003 kilograms. Here's the code. Essentially here on the left side, all we did was create the E field function, which is going to be called here, which is going to be called later. Here we're creating, this is the function to define a line charge, and here we're creating the two charges that are going to be modeled in the visual. And then this is the code that calculates the electric force. So this code is a iterative process that goes through each and every of the 100 point charges we had given by this n equals 100. Eventually, here are the results. So we got a magnitude of the electric force being equal to the magnitude of the gravitational force, and that gives us the charge of 2.794 times 10 to the negative 8th. So since the two forces are equal, this is what was reflected in the model. We know that this is similar to what was happening in the actual experiment. So the comparison between the models and the real-world experiment, both models model the real world and what's happening. Lab 2 just does it better because it models it as a line charge rather than a point charge, which is closer to what's actually happening, as the tape has a series of charges rather than one single charge in the middle of its length. Although Lab 2 does a better job modeling it, we can still make a more accurate model by accounting for other factors such as airflow and modeling the tape as a surface instead of a line, which would be even more accurate for the charge. Sources of error, there are many, but the two main ones I listed were error in finding the distance between the two tapes, so like human error, and assuming both tapes are equally charged. So what if each of your tapes was taken as a point charge? Well, it'd be like in Lab 1, which we got a charge of 8.5776 times 10 to the negative 9th, where in this model, where we modeled it as a point charge, we got 2.79 times 10 to the negative 8th. This is a difference of 3.25, as I mentioned in the introduction. So why do these estimates differ? It's because we calculate it using a different model. So it's not actually modeling exactly what's happening in this lab. So we can take steps to make it more accurate, such as modeling the tape as a surface rather than a line of charges. Thank you.